And now for our last three problems. We have number 21, which isn't going to use a conjugate just yet as it's written. So we have the square root of 3 divided by 3 times the square root of 2. And we have the square root of 2 divided by 2 times the square root of 3. Now, in order to add fractions, we have to have a common denominator. And even though these denominators look similar, different numbers are in the radicals, so we cannot add them as they're written. So what we need to do is we need to get a common denominator. Now, before I worry about getting a common denominator, the square root of 2 and the square root of 3 are kind of messing things up. So I'm going to go ahead and rationalize each of those fractions separately to get rid of that square root in the denominator. So I've got the square root of 3 divided by 3 times the square root of 2. I'm going to multiply that by the square root of 2 divided by the square root of 2. The second fraction has the square root of 2 over 2 times the square root of 3. I'm going to rationalize that by multiplying by the square root of 3 over the square root of 3. Let's go ahead and see what that ends up producing. So the first fraction, we get the square root of 6 up top, and you get 3 times 2 in the bottom. And over here we get the square root of 6, and you get 2 times 3 in the bottom. Now if I go ahead and look at what that gives me, I actually have 6 in the denominator of the first fraction and 6 in the denominator of the second. So I have a common denominator that I can add. Now remember, when you add fractions, you just add what's in the numerator. The denominator does not change. So my denominator is still going to be 6. I've got the square root of 6 plus the square root of 6. That's 2 of them. And 2 divided by 6 reduces to 1/3. So, could have done that in slightly different order, but this is pretty much a logical progression. Get the square root of 6 divided by 3. Alright, now number 22, I've got 6 divided by the square root of 3 plus 8 divided by the square root of 2. This is a very similar problem to 21. And so before I can worry about getting a common denominator, I'm just going to get rid of those square roots in the denominator. So 6 divided by the square root of 3, I'm going to multiply by the square root of 3 divided by the square root of 3. And 8 divided by the square root of 2, I multiply by the square root of 2 over the square root of 2. When I do that, my first fraction has 6 divided by the square root of 3 over 3. And this has 8 times the square root of 2 over 2. Now, you want to be careful here. I could do a lot of extra work and get a common denominator and then reduce at the end. But I'm going to go ahead and reduce as I go. So 6 divided by 3 is 2. And I don't have anything left in my denominator. And 8 divided by 2 is 4. And I don't have anything left in my denominator. And there is my answer. Last one. Now we're back to one that's going to use a conjugate. This one actually is very similar to number 19. So if you got number 19 right, then you're doing good with this one. So my conjugate is going to be the square root of x minus the square root of y. And I'm just going to go ahead and put in those parentheses. Parentheses are your friend, and they'll help me not to get anything mixed up. Denominator's easier to figure out here. Your first term squared is x, minus your second term squared, which is y. Now up at the top, I'm going to have to actually FOIL this out. So square root of x times the square root of x is x. Then I've got minus the square root of xy. And again, I got minus the square root of xy. And then I've got plus y up at the top. So I'm going to go ahead and do some combining of any like terms I can. So I've got x minus 2 square root of xy plus y all over x minus y. Now that right there is as far as you can go. Sometimes people make the mistake of, oh, well, I see these x's, I want to cancel them out, or I see an x and a y in the top and an x and a y in the bottom. It doesn't work that way. You cannot do any more reducing than what you have right here. So that's your final answer.